In this lesson, we'll talk about end behavior, which is what's happening far to the right and far to the left in a graph. And we'll also use limits to describe that. So, what are the possible behaviors of a graph So let's think about what could happen far to the right in a graph. We can have the graph flatten out and approach some y value far to the right, or the graph could go down to negative infinity, the graph could go up to positive infinity, or the graph could just go back and forth, and that's called oscillation. So let's find out, and we'll call that end behavior. What happens far to the right is end behavior. Also, what happens far to the left is end behavior. So let's find the end behavior. Oops, we don't need that there. Okay, so the end behavior, if we think of what's happening far to the right, we can just look at f of 10 is 940, f of 100 So we look at what's happening as we go far to the right in x values. The y values are going to, they're just getting larger and larger, and we see that as x goes to infinity, f of x goes to infinity. We could write the limit as x goes to infinity of f of x is infinity. All right, so why don't we just change the question to and just add in as x goes to infinity, determine the end behavior to the right, because we'll look at other examples where we're looking at both sides. I just wanted you to see how do we go to the right. We just choose large numbers going to the right, and we look at the y values. What are the y values doing? All right, so to find the end behavior, let's make a table. And Now we're not looking at the limit at a number like in the previous lesson. We just want to go far to the right, far to the left, and using a calculator, here we have 3 times 10 to the 8th, or approximately 3 times 10 to the 8th. And then we look what's happening to these y values. We have about 30,000. Then we have a big number here. It's going higher. So we'll say it's going to positive infinity. Here they're also positive going this way. We're going to positive infinity. So when we look at the graph, it's going to positive infinity to the right, positive infinity to the left. So we say the limit as x goes to infinity of f of x is infinity. The limit as x goes to negative infinity of f of x is positive infinity. So make sure we know the difference between what these two are. That's the x value and the y value, x value. This means go to the left. This means go up. Go to the right and go up, shown in the graph. All right. So do the same thing for this. Describe the end behavior. Pause the video. And using a calculator, we have 1242, 1.03 times 10 to the 6th. So looking at that, these numbers are going to positive infinity. Here we have negative 638, negative 9.7 times 10 to the 5th. A large negative number, so this is going to negative infinity. And if we visualize that, going to the right, it goes up. Going to the left, it goes down. And we can write it as the limit as x goes to the right of g of x is positive infinity. The limit as x goes to the left of g of x is negative infinity. And let's do okay. And pause the video and try that one. All right, going to the right, the y value is going to negative infinity. Going to the left, the y value is going to negative infinity. And if we look at the graph, it's going to negative infinity on both sides. And we can say the limit as x goes to the right that's going to be negative infinity. The limit as x goes to the left, and that's negative infinity. And we don't have to do the same thing on this. I'll just tell you that this one's going to go down to the right, up to the left. And now let's go back and look for a shortcut so that we don't have to make a table every time. So let's look at, compare this to the other polynomials. So that's what we've seen so far. And the shortcut is, without having to make a table, we just look at the highest exponent, call it the degree of the polynomial, look at that term with the highest exponent, and then we look at whether it's a positive or a negative. So here, negative means go down to the right. Positive means go up to the right. Positive, up to the right. Negative, down to the right. Then, after we determine what happens to the right, we can look at the even or odd exponent. So odd means do the opposite of what you did. So we're going down to the right and then do the opposite. Go down to the right and then go up to the left. Alright, this means go up to the right because it's positive, but even means do the same thing. So we're going to do the same thing on both sides. Positive means up to the right, odd means do the opposite. So up to the right, down to the left. Here we're going to go down to the right, do the same thing on the left. So down and down, and there's the shortcut so we don't have to make a table every time. That's for polynomials. Okay, and then we have rationals. So let's make a table for that. We still just make the same, use the same strategy. We have to go far to the left and far to the right. Just be careful when you enter this in the calculator that you enter it with parentheses in the numerator and denominator. So we have 0.50249, 0.5238, 0.4737, 0.4975. We want to know what's happening going to the right. It looks like it's going to 0.5, and going to the left looks like it's also going to 0.5. So we can say that the limit, the end behavior as x goes to the right is 0.5. The end behavior as x goes to the left is also 0.5. So here it's not going to infinity or negative infinity. Alright, and do the same thing with that. (1.5 times 10 to the negative fourth), and on your calculator it might say 1.5 e negative 4. Sometimes they write it like that, but that means that, and we know that this is a very small number. So we see that 0.01, this will be 0.0001, and we know it's going to 0. So going to the left it's also going to 0. The y value is going to 0. So we can say the end behavior as x goes to the right of f of x is 0. The limit of f of x as x goes to the left is 0. Alright, one more. Okay, make a table and find the end behavior. Pause the video. So we have 2.9314, 2.417. And if you can't tell what number is being approached, then you would just choose a larger x value and find out what you're getting close to. These y values are getting close to 3, 3.875, 3.0714. These numbers are getting close to 3. So we can say the limit as x goes to positive infinity of the function is 3. The end behavior is the graph approaches 3. The limit as x goes to negative infinity is also 3. And that's the end behavior. I'll stop there.